Welcome to all the participants to today's session of the Industry-Oriented Statistics for AI, Machine Learning, and Data Science Training Program. Today, we bring together concepts and techniques covered throughout the training program through a highly practical and application-based oriented session. Project presentation using real data and ML model. This session provides an opportunity to apply statistical concepts, data analysis techniques, and machine learning methods to real-world problems and datasets. In today's session, we will present projects demonstrating how real data can be collected, explored, cleaned, analyzed, and transformed into meaningful insights. We'll also focus on the development and application of machine learning models, including the process of selecting an appropriate model, training it using the available data, evaluating its performance, and interpreting the results. Working with real data is particularly important because practical data sets often contain missing values, inconsistency, outliers, and other challenges that may not appear in theoretical examples. Through these project presentations, we will not only examine the technical implementation of machine learning models, but also understand how data-driven approaches can be used to solve practical problems and support informed decision making. I encourage everyone to actively participate, carefully observe each project, and think critically about the data, methodology, model selection, and results presented. This session is an opportunity to connect the theoretical knowledge gained during the training with practical industry-oriented applications. Now I'd like to invite Dr. Meher Chand, who has been instrumental in guiding this workshop and bringing together practical applications of AI for leadership, research, training, and education. Over to you, sir.
Thanks, dear Face, for the nice introduction. And good evening, all of the participants. Welcome back to our ongoing workshop. Today, we will use the real data set. Okay, so the main objective of the today's session is how machine learning models we can develop by using Python. Okay, so this model will help you in the coming sessions, which type of the techniques, methods, and the process. Main thing is the process to develop a machine learning model, how we can do. Okay. So because as I told you yesterday that you have to also develop one model during the coming sessions. Okay, you will prepare and after that you will submit the same on the last day. And also we will discuss from where you can assess the data set, because main thing is for practice purpose, we need some data set. Okay. By using the data set, we can develop one machine learning model. So I am going to share my screen, which is visible to all of you. And just all the model is already complete from this side. You need to understand only what we are going to do with the data set, and also how you can write your entire project. You will prepare the project file. Okay, so here this file which you can see is student performance prediction system. This is the one of the model. Okay, and the data set which we are using here is a student data set. About 10,000 entries are there. If I will click on it, this will open here. So here you can see the study hours, attendance, sleep hours, internet uses, assignment completed, previous. Okay, so all these are the parameters, previous score, exam score, and placement status. So when one student have the placement status, so behind all these, the parametric values which you can see here are very useful. And on the basis of all these parametric values which are associated with the performance of the student, specifically placement status. And at the end also, we will observe that the exam score is very, very important. Okay. So to get the exam score also, the other previous parameters always help to score good score in the examination. Okay, so this dataset we are using, and the entries of this dataset is about 10,000. Okay, not about exactly 10,000 we have. You can see this is the real CSV file, and up to 10,000 entries are there. Okay, so this data set we are using. Now I close this file, no importance, because everything we will do in this file, which I will share with you, both the file, project file by using Jupyter Notebook, as well as the data set, both will be available for you. So that on the very first level, you will understand all the steps. So when you will be familiar about all these steps and many things we already has covered during the past session. Okay, see now, yes, so all these things you will maintain, and the abstract you can write yourself. So here we use regression analysis and classification analysis. Regression for exam score, okay, and the classification analysis for predicting the placement status, okay. As you can see, so through the exploratory data set and the predictive modeling, our analysis reveals that the consistent attendance, structured study hours, solid historical academic foundation are the strongest indicator for both higher exam marks and successful job placement. The resulting prediction systems serve as the proactive decision support tools for the academic counselor and institution administrator, enabling early intervention, personalized mentorship, and targeted resources allocation before final examination and recruitment drive. Okay, so this is the problem which we have taken here on the basis of the data set. Okay, so this is the entire problem statement in the modern education setting. Academic institutions often face the challenges in identifying the struggling student early enough to provide effective intervention. Traditional evaluation method rely heavily on end to of examination and final assessment static. So which act reactive matrices rather than a proactive indicator. So here these are the some objective. Okay, so I will come to direct our implementation part. Okay, this literature part we can easily read out. So here we are using mainly the libraries which you can see, pandas, then numpy, and also what are the use of all these libraries. Okay, pandas, very smart library. Specifically, we use it for data frame. Okay, so once we have the data frame, after that, all type of the operations which we are required for loads, clean, manipulate the data set. Okay, we can read CSV file, Excel file, any file which contains some data set. Okay, info is null. So these are types of the operation we can apply. NumPy provides the fast numerical computing and multi-dimensional array operation behind pandas and machine learning model. Why we need matplotlib? Standard plotting library used to create a base graph, set plot dimension, labels, render visuals. Why we are using Seaborn? Advanced visualization library used to plot stylish statistical chart, and SNS.heatmap for confusion matrix. Okay, so confusion matrix we will get when we have the machine learning we have model we have developed, but after that testing is uh, very important. So for that some matrices test are required. Okay, those also we will cover here. We will try to cover, but first of all we should have the information how and what type of the tests are there and how we can implement. So all this part will be the of this today's session. So first, one also you can see this is the scikit-learn. sklearn. So this is the core machine learning library used for dataset, separating, training the model, and computing evaluation metrics. So these libraries are very, very essential for to develop any machine learning model. Along with the statistical part will also will be there, but which type of statistical part we need to cover here? Okay. See now, very first we have to import these libraries. Okay, I can execute the entire file by press this icon as you can see. Okay, so first I would like to make it in toggle zone. Yeah, and then after I will execute this one so that I need to present only. This will execute all the shell which are available in this file. Yes, so you can see the library which are required has been imported here. Then this is the file name. This is the file name of the dataset which contain, as I have shown you in the very beginning, the same file name we are using here. Okay, and pd.read underscore csv. Okay, and also at this place, don't forget to use the name extension of the file. Here we are using CSV file. So here we need to use the full name of the file along with extension. Okay. And here you will use CSV also. So this is the way how you can read the data set, and we are required to store in some variable. So the variable we are using here data. So this variable now contain all the information which is available in our CSV file. So we are not required to use this file, this statement, because the information is available at this place. Okay. So when you will use only the simple data here, so which is available in this place. So this statement data will print the entire data set. Okay. Starting from 0 to, but only the first 5 rows and last 5 rows only. Okay, and three dots meaning the continuity in the entire data set, and along with the you can see 10,000 rows by 8 column. So this is the size of the data set. Okay, so first most important thing is to import the data set by using Jupyter notebook. Okay, and yesterday I think one participant was asking in the WhatsApp group, or I don't know whether in the personal chat, how to read the CSV file. Okay, so I hope the from this person was asking has been resolved. Okay, because the lecture I have shared and all the list of the lectures which we have held in the previous sessions, complete playlist is there in the WhatsApp group, so that if there is any missing lecture from your side, you can cover, and all the content day wise also available in the WhatsApp group. Okay, so everything is there in the WhatsApp group systematically, and later on we will create the Google Drive link also, so that we can upload all the content day wise, and also these content will be available in your account. We will inform you later. Sometimes Google Drive link may be not work because of huge data set. We delete the link. Okay. So in your account, all the content which we present with the recordings will be permanently available. You can access all these content anytime in your future. So this is all about the dataset which we read by using the. Then after that we are required data set overview and the variable dictionary. Okay, so you can see this is the information. Okay, so what you can do for that? This is all about the column names, then data type, description is given here. Okay, so 10,000 data set is there, but here we need print column name. For that you will use here data dot shape one. Okay, so only the column name one we are using for row. Okay, so we need only row. And then in the next we have the column names. Okay, so the number of the columns we have is 8, and these are the column names. Okay, these are data dot columns. So this will return the column name. Okay, so study hours, and keep in mind we have to use the name as we have in the data set. Okay, so the good thing is that you can, whenever we need, we use this command to access the column name, and just you are required to copy the head name whenever we need to use all this. Okay, so that any kind of, sometimes if you are using S in the uppercase or H in the uppercase, or sometimes this space is missing, so this will return error. So Python is very sensitive. Not only Python, all the programs are very sensitive. So if you have the correct mapping with variable, only then we can have the output. Otherwise, no output. Okay, so if you want to assess the only the number of the rows, data dot shape 0. So 0 will return the number of rows, and here we are getting the data dot shape 1, number of column. How many columns are there? So that's why you can see here the columns are 8 and rows are 10,000. If this statement also we used previously in the session, okay, data dot head, this will return the first 5 rows entries from our data set. If you will use here address space tail, in that case the yes, you can see tail is also there. Last 5 entries will be there. Okay, if you want to access some more rows, you can enter here 10, 15, 50. Okay, so 50 rows will be there. Also, you can use here also address space numerical value 10, 15, or 50, whatever you need. So by default, this will be 5 for first entries when we are using head, and 5 also from last when you are using tail function. Okay, info, you can see the same function which we have used in the previous session. So some parts of this project file. Okay, you also, when you will get one project, the same steps you have to follow as we are doing in this file. Okay, so data.info, because these are the steps which we are required to understand the entire data set, what information is there in CSV file. Okay, so one by one, we are not able to read everything, but these functions which are very short in use and will return all the information about your entire data set. Okay, then you can see we have the data type. So you can see here, these are integer value and only placement status is object. Okay, it means this is non-numerical value. And if you want to check the duplicate entries, so here data dot duplicated, so all are false. There is no duplicated entries. If you want to check the describe, okay, describe means descriptive static. Okay, we are using describe for descriptive static, or also you can use here dot t. Okay, control and enter. Okay, so you can see this is now in transpose form. So count, means, STD, minimum value, first quartile, second quartile, third quartile, maximum value. So minimum and maximum, these values are very, very essential. First quartile, second quartile, third quartile, also very useful to understand the entire data set. From this, we can get all the information, and you can see all the entries are equal. It means there is no missing value in any variable. Okay, and here is the mean of all these. Sometimes SD is also there. Minimum value and maximum value also give us some range. What are the minimum value and maximum value in our data set with respect to all the variables? Okay, so here the target variable. Now, exam score and placement status. These two variables are our target values. Okay, exam score, continuous and regression target. But placement status, binary classification, placed or not, because there are only two options, whether the student has been placed or not placed. For that, we have to use only binary classification. And exam score, we have, you know, on the basis of the previous data set. Okay, so this is the continuous and regression target. Okay, so here now you can see we are required describe target value. Okay, so first we are taking here exam score. In this address space, we have only the exam score. You can use the describe function. So these values you can see. Similarly, we can have the placement status describe. So here the count is 10,000. Unique values are 2. Top value is placed. Frequency is this one. Okay. So by using all these functions, just we are understanding what information is there in our data set. So that here you can see also the handling the missing values. If there are any missing value, but by default in this data set which we are using, there is no any missing value. Okay, that's why when you are using here data dot is null dot sum and all the entries of the variable you can see 0, it means there is no empty cell. All the values are there. Okay, so one by one variable we check cross check at this place also. But here when you are taking the descriptive static from that pass also you can see that all the values are equal. It means there is no missing value. But also we use here this function also. Okay. So if there is any duplicate value, handling the duplicate value. But here in this data set, there is no duplicate value, duplicated dot sum. So you can see when you are using this function, the values are 0. So in this way, we don't have any duplicate value. Also, here we are changing the data type. Okay, exam score, data exam score, dot age type float. So all the values you can see exam score will be converted to float values. Okay, so by using this one, and they will be updated in our main data set. So now when you will execute, you will print the data set. You can see this column exam score are in float values. Okay. Then you can have the data size is same, no change. Now we have the
Uh,
exploratory data
okay,
analysis.
sir.
Yes, please. Yeah, Dr.
If there are
Shamsundar, yes,
missing
please.
values in the variables, how do we deal with it? Whether we have to drop it or we have to replace it? So
Yes, yes, yes. If there is any duplicate value, we can drop it. Okay, we can drop it. But here the data set which we are using, there is no such problem. Okay, so in the coming sessions when you will start, okay, or if there is any missing value in the previous session also we discussed this part how we can drop the value if there is duplicate entry. Okay, and also we use filna function if there is any value is missing. So for that we can use average or according to by using the formula main or frequency means mode, highest frequency value we can use. Okay, or we can use STD. So one of them we can use the formula to fill the missing value. Okay, so if but in this file which I am using here, only what you need to understand here only the workflow. Okay, this is a very simplest model. So that once we are able to understand the workflow, what steps are essential, how state will play the role to develop a machine learning model, and how we clean the data set, which steps are there. If there is duplicate entries, we have to delete the entries. If there is any missing value, we have to fill the missing values. But if we have the large data set, we can also drop that variable, that entries. Okay, so there are many ways how we can manage, but depend upon the size of the data set. Okay, suppose if we have only the 500 entries are there, and due to the missing values, or 50 entries or 70 entries, we are going to delete. So the size of the data set will reduce. But if you have the very large data set, just like you can have more than 50,000 entries are there. If you will drop 2 or 3 or 10 entries or 50 entries, 10 entries, there is no big problem. Okay, but when we have the small data set, in that case, we have to manage our data set very carefully. So all these operations depend upon the size of the data set, which type of the data we have. Okay, and sometimes also we have to delete the columns. But when we need to delete the any column, then we have to check uh, correlation, association with the other variables, whether it is having the more impact on the, you can say, highly correlated with the other variable. So we have to keep the same variable. So when we are applying all these operations, first thing is to understand, okay, the depend upon the size of the data set, whether we need to delete or whether we have to adopt another technique to fill the data set. So data cleaning and pre-processing, these two terms are very, very essential here. Okay, so uh, here you can see exploratory data analysis. Here we are using to visualize for better understanding about the entire data set. Okay, so these libraries, as you can see, we have import already in the very beginning. And when we have the large data set, in that case, we have to use also Seaborn. Okay, already these libraries has been imported, but again, here we are using. Okay, so for that, what we should do now, uh, here you can see this is the figure size. Okay, and here we are using the data.copy. This is the temporary data set. Okay, so in this data set, we are using only the, you can see here, placement status. Okay, is equal to, see here, placement status dot map placed 1, not placed 0. Okay, and SNS dot heat map, we are generating here heat map. So for the large data set, if we have any kind of a graph, okay, just like a bar graph is there, histogram, plot is there, heat map is there. So this actually SNS library manage everything and for the complex data set. Okay, so here this is the correlation, you can see temp underscore data dot correlation. So this is the correlation function. And when we have the correlation matrix, so by using the same matrix, we are using heat map, annotative and CMap full form and FMT dot, this is the format, okay, dot to F, up to 2 decimal places we are using. And line width we are using 0.5. Okay, so when you will execute all these are the titles and PLT dot show, which we are using usually. So this is the heat map. So all these values are of correlation matrix, but we are present all these values in the form of a heat map. So here you can see this is the study hour and this is the placement status. Okay, so the value is 0.40. This is the correlation value. Okay, this is the value of correlation, association between these two variables. And similarly, you can see rush between these two variable, then this variable, and so on. But here is placement, and in the last column also we have placement. So this value is equal to 1. So one variable when will be associated with itself, the value will be equal to always 1. You can see all the diagonal element are 1. Okay, so when you will see this variable, so here is exam score and here is also exam score. Okay, similarly this variable is also 1, previous score and previous score. Okay, so we need to compare with other variable. So here you can see the colors are representing their uh, association or the relationship between the variable. Okay, so this is the right side. You can see on the right hand side, this is the bar. Okay, and from this bar you can see the values are varies from suppose this is approximately minus 0.1. Okay, minus 0.1 to 1.0. So the values of these all correlation matrix lies between this range. And these color, you can see when we have the value is 1, this is the darkest red. Okay, if you can see uh, this color, this color is approximately very close to at this place. Okay, minus 0.1 approximately. Okay, so the dark color are saying the negative correlation, and blue, light blue, you can see these are very close to 0, and dark blue close to minus 0.1. Okay, and if you will see this orange color, this color, okay, is approximately nearby 0.6 or so on. You can see this value, this value, this value. Okay, and this value. So by seeing this bar graph or heat map, we can easily understand which variable have positive correlation, which variable have negative correlation. So this help us to understand about our data set. Then data insight, we can choose different variables. Okay, so for that you can see here analysis the data from exam score and placement status. So what we are doing here, this is the matrix, two graphs are there. Okay, so here you can see distribution of the exam score, numerical target, and here we are using subplot, PLT dot subplot 1, 2, 1. Okay, here 1, 2, and here is also 1, 2. The meaning is that in one row and two column, the images will be in the form of just like we have one row and two column matrix. Okay, so there will be two graphs in the single image. Okay, and the meaning of this one is this is the first graph and this is the second graph. So here we are using PLT dot subplot and PLT dot subplot. So here from the data set, okay, we are using SNS hist plot, data is equal to data, and from the data we are using X is equal to exam score, and along with we have caddy curve. Okay, and color we are using blue, and PLT dot title, this is the title of the image, and on the horizontal line PLT dot X label, exam score, and second is associated with the placement. Okay, so here variable we are taking X is equal to placement, and color we are using light green, and title is count of plot versus not placed student, and on the horizontal line we have placement. So when you will execute, there will be two graphs. One is set for the exam score, second will be for placement score. This will help us to understand. You can see this one. Okay, so as the exam scores are increasing, okay, so here the maximum students are there. Okay, so this is the category also. You can see how it is increasing. And on the right hand side, you can see the count of placed and not placed. So here these are the not placed and these are placed. Okay, so this will help us in the two graphs. According to our inputs, we can have the visualization in the single image, and size, you can see the image size which we choose here, 12 by 5. Okay, so length is 12 and height is 5. Then you can see the various images are there. Here we are comparing study hours effect on the exam score. Okay, so here we want to understand by visualizing the graph. Okay, so this is the way how you can use it. We have the two variable. This is the size, and from the data we are taking two variable. One is x variable, that is the study hour, and second is the y is equal to exam score. So if we spend more time, we have the more score. Okay, and you can see here. Okay, so when this the color light color we are using light red, and the title is impact of the study hours. Okay, and X label we have the study hours per week, and Y label we have the exam score. So you can see as we are spending more time on study, we have more score. So this is the horizontal line, and at this side we have exam score. Okay, so all these operations which we are using to help the to understand the entire information, how the time hours or the other variables can have the impact on the exam score. But exam score and placement. Placement will be based on the exam score, and exam score will be depend upon the previous habits. And in the habit, we can say the sleeping hours, time which we spend on it, and previous score, assignments, all these are the sportive parameters. Okay, so all these we consider one by one. So here also we have the our previous performance drive with the final exam score. Okay, so the same variables we are using here. Rig plot. Okay, this is the regression plot. Okay, so you can see the impact, a correlation, past academic history versus final exam score by using these two variables. On the horizontal line, we have the previous score, and here is exam score, and you can see the impact. Okay, so previous score, study hours, all this will increase the final exam score. Okay, so here also we try to insert here the interpretation. Similarly, we can have the comparison between, here is the comparison, academic discipline, assignment completed versus average grade. Okay, these two are comparison compared at this place. So I can skip all this part, come to here. This is very interesting. So here you can see, anyone can please expand this one, this diagram. Anyone from your side? Anyone? Control minus. I think now it is perfect visible, complete image you can see.
How
This
the
diagram,
exam score, yeah, how the exam score is spreaded against to study hours, within placed and not placed. It is a
yeah,
kind of, within placed and not placed. How the
uh,
study hours distributed among the exam score.
yes. And also, what about this right part or on the top side, the curves which you can see where my cursor is moving? What about this?
That is the distribution of data where data is concentrated, right? Right hand side, it's showing that distribution.
For exam score.
Yeah, correct.
Okay.
Correct.
Actually, this graph is associated with the exam score.
Yeah,
And
yeah.
this is associated with study hours. Thank you,
Study
sir.
hours. Yeah.
Yeah, thank you. Thank you for your support. Okay. So all the, yes, Engineer Prakash, yes, thank you. So this statement we use at this place, okay, and very simple too. So actually, all these we are finding the association and impact of the study hours, exam scores, all these we are comparing for the better understanding, okay, by visualizing. So this is the behavioral dynamic, okay. So the same thing you can observe here: study interaction, previous score, and exam score segmented by placement status. You can see this is the previous score, and here is exam score. And on the basis of on this, how the placement status. So you can see this color schedule plot. Okay, so based on these values, this part is placed, and this part you can see in the blue color is not placed. Okay, and how the data is scattered, the same thing as we discussed in the previous image. Okay, so here also we have more comparison, assignment completed and exam score. We are comparing here for the placement status. Okay, so you can easily go through all this. Yeah, here is one more interesting is you can see. So what we are doing here, we are using the final verdict, feature impact ranking placement. Okay, so here See, what you are observing from this place?
Internet usage is having negative impact compared to exam score.
Internet uses. Yes, yes. Good, sir. And other have some positive impact. If we sleep more,
That's our
okay,
positive.
sleeping, attendance, yeah, all these have positive impact. And internet uses has negative impact. Okay, so by seeing this visualization, we can easily understand our data set and the information and the impact. All these, why we need all the visualization which we are saying, which we are using here, why all these part are necessary for us? Can you please anyone explain this part? We have visualized in many different way by taking two variables and we are seeing their impact. Okay, so can you please anyone explain why we need all this type of the visualization for making some intervention to help? Yes, yes, someone is saying.
Yeah, to prioritize the future, which is highly impacting the exam score, positively or negatively.
Mm,
So
yes, yes.
we cannot use all future for predicting why. So we need to prioritize. So this will tell us, okay, what are the futures is highly impacted for exam score.
Mm. And also one more thing, this is good, and I want to add some more information. If you have the entire information in the visualization format, so when we write the report, okay, all this information will help us to write the report as a storytelling, so that anyone who will read the report can easily understand. Okay, from the huge data set, we are getting some insightful information. Okay, so everyone can't understand the data set. Okay, but by using this information which we are visualizing, all these help to those people who don't know mathematics, who don't know about the what is the state. Okay, but they can understand these graphs which we present here, and all these help us to write the report as a storytelling. And story is very interesting and everyone can stand and take the interest. So when we have this type of the information in our report, and we are able to write everything, and also all this information which we visualize will help us to develop our machine learning model. So by using all these type of the different operations, we are trying to understand the entire data set. Okay, now here we are problem solving statement and key findings. Okay, so now we are able to develop our model. Okay, so what are the key insight from the data? Primary drives of the academic status, study hours, attendance, previous score shows the strongest positive correlation with exam score. And placement factor, students with the high attendance and exam performance exhibit a significantly higher probability of achieving place. Okay, and lifestyle impact, balanced sleep pattern, okay, positively correlate with the performance, while excessive internet uses without structured study activity, negative impact. Okay, so this is the overall information from the previous task which we perform. Okay, now how this system solve the problem? Okay, we go to all the information. Now we want to develop some technique so that this can help us for the prediction purpose, or how we can solve this problem when we observe with our students or in the classroom. Okay, so see now, early warning system. By inputting current attendance, previous score, and study habit, administrator can identify at risk student before final exam. Okay, and targeted mentorship, focus institutions resources and tutoring on the student predicted to fall below placement eligibility threshold. Okay, so these two prompts are there which we can monitor before the final exam. Okay, for that what we are doing here, we are using now machine learning model. This will help us to find out the solution and how we can predict on the basis of the behavior or the previous score, and we will compile all this in the single place. See now, here we have to split the data in two parts. The first important thing is we have to split our data set in two parts. As you can see here, X variable, all these parameters which you are observing here are independent. Study hours, attendance, sleep hours, internet uses, assignment completed, previous score, all these are in the hand of student. Okay. Then Y-reg, you can see here data, exam score. So based on these habits, okay, we have the output. So output is the exam score. Okay, then you can see the other is CLF. Okay, so that is based on placement. Okay, so these are both these output will depend upon these independent variables. Okay, so what we are doing here now? First, we will develop here feature importance of the regression target score. Okay, so actually, when we use this feature regression, okay, so estimator and random state. So number of the estimator we are taking here 100, and random state, this is not the particular value. We can use any value here. Okay, so just like you can take here 0, you can take 1, you can take 2, you can take 3, you can take 100, we can take 1000, any value for the random state. This is not the any method does not exist to choose random state. But for the number of estimator, that also we can fix 100 or 200. Okay, so this is the random forest regression we are using here. And this is one of the machine learning model based. Okay, so we at this place the machine learning scikit-learn, which we in the starting we import the library, okay, which is used for machine learning. Where is scikit-learn? Anywhere we have import this one. Okay, so from that we are using this model. Come to okay here. Then we will fit the model which we are using here, random forest regression. Okay, there are so many models are there, but here we have to use random forest regression. Okay, for regression target. Okay, and here we fit the model X variable and Y variable for regression, which we are using exam score. Okay, so this will fit the model, and then importance PD dot series, and here the feature importance will be there, and index X dot column dot sort the values ascending. Ascending is fast. Okay, it means this will be in descending order. Then we have the feature importance of the classification target, placement status. Okay, so for that we have the same model forest classifier, and here we are using regression. Here we have to use classifier. Okay, and the other input we have the same. So here we will fit the model. This is the variable. Sorry, this is the variable as we use here. This one. Okay, and here we fit the model dot fit and X comma Y CLF, and then CLF importance as we do for this one. Okay, so this is the rest, the same thing. Then we will visualize that plot feature importance. Okay, so here this is the PLT to subplot with two plots will be there, and these are the input statement to visualize the graph. Okay, so here you can see. Here you can see we have both the graph. First one is for regression. This is feature importance for the target exam score regression, and right hand side you can see for the classifier. Okay, here these are the importance score, and then this side also we have importance of scores, and these are the other parameters. You can see sleep hours, internet uses, attendance, previous score, assignment, study hours, and here is the, you can see the same parameters as we use in this side, and this is the study hours. Okay, so these are the importance score. You can compare both them. Okay, one is for regression and other is for classification. Okay, so here is the also the interpretation of the above both. You can easily go through this detail. Okay, then for left plot and for right plot, one is for regression and second is for classification. Okay, so for that summary table, this is the very important part for us. This is very important. So how you can get the summary of this table? Okay, so here feature summary data frame. In X column, we have the features. Okay, the meaning of the feature means how many variables are there. Okay, then we have the importance exam regression. So here the values are only, and then we have the importance placement. Here CLF importance which we get X column values, and then dot sort values. Okay, in ascending order, and these are used here to print in string format. Okay, so when you will execute, you can see this is the entire summary about feature selection analysis. So here, sorry. Yes. So you can see here, these are the features: study hour, assignment completed, previous score, attendance, internet uses, sleep hours. And here are the importance exam score. Okay, and these are the importance of placement scores. If you need the interpretation of these, okay, so you can take this part for detailed interpretation. I can come here. So along with in the beginning, you can use here slash interpret. Okay, so with the help of this, you can see we have detailed interpretation. Okay, so the interpretation which you can see, if I do manually, not easy, but here with the help of generative AI tool, we can have the detailed interpretation for more understanding and to write the report in very detail. Okay, so if you will compare these two parameters, most important predictor of the exam performance and also highly important. So all these are the interpretation based on these values. Okay, and these are the key finding. Okay, what we get to the key finding from this summary report, and this is the overall interpretation. Okay, this is the overall interpretation. The analysis suggests that the consistent study habit and the academic engagement are the strongest predictor of the student success. In particular, increasing the study hour, completing the assignment, maintaining the good academic performance, and regular attendance appear to be important factor associated with the both examination performance and placement outcome. Okay. So why I use here? Because when we have the confusion matrix, okay, the complexity will be increased there. Okay, so in the beginning, if you need to take the help of this generative AI tool, just like by using the Gemini AI or ChatGPT or the Claude, we also can take help too for the detailed interpretation so that we can have, in the minimum time, we can get to the right information. Okay, so yes, come back here. Here we have the scikit concept of the scikit-learn machine learning model is there. So there are some steps which we have to follow. Okay, there are some steps. The first part is to split the data. To split the data in two parts. So mainly what we do for training the model, we have to split the data just like 70% for the training the model and 30% for testing the model, or we can have 75% for training and 25% for testing, or we can choose 80% for training and 20% for testing. And in all of the model, these are the options which we can choose. So maximum data we have to use for training and very less data is used to for testing. Okay, so this is the process, data separating and pre-processing. So for to separate the data, we will use this function train underscore test underscore split. Okay, so in two part, by using this function, the data will be divided into two part. One will be for training data and other will be for testing data. X variable contain the features matrix. Okay, these will be the independent variables, or you can say inputs. And Y is the target vector. Okay, or you can say these are the output values. Then test size, as I told you, test size. Okay, the proportion of the data set allotted to the test is, you can see here 0.2. 0.2 means 20% data set will be used to test and 80% will be used for training. Okay, and random state. So as I told you in the very beginning that there is no such any fixed rule. Okay, control the random shuffling of the data before separating to ensure reproducible and consistent result every time when you run the code. Okay, but the value which we are using, just like 42 mostly we are using, there is some history of a data scientist, why he was using 42, and from that the concept every data scientists are using 42. But if you will use 40 or 45, 100 or 10, there is no difference. Okay, actually when is whenever you reproduce the result will be always same, but we have to assign the value for random state. Okay, then in the next step, core model. This is the core model, fit X train and Y train. Then we have the predict X test, and then after we have fit underscore transform. So this will fit the transform like standard scalar to the data and transform into the single step. Okay, then after we have machine learning models. Okay, here we are using linear regression for this is the regression model and used to predict the continuous numerical value. And we are using here for the exam score. And second one, we have the logistic regression. This is used for classification. Okay, a classification model used to predict binary categorical outputs, just like placed or not placed. For that, we are using logistic regression. And then after we have the decision tree classifier. Okay, or random forest classifier. These are based on the tree-based classification algorithm that make a prediction by spreading data along decision tree. Okay, and after that we have to use the model evaluation matrix. Okay, this is very important part. So when you will use this algorithm as we discuss here, sometimes we have a very high accuracy, just like we can have 90, we can have 95, we can have 99%. But if we have the 99%, it doesn't mean that our model is accurate. For that, model evaluation matrix is very essential to validate the model. So for that, we are using the accuracy score, measures the percentage of the total correct prediction made by the classification model. These we will discuss in the very detail in the coming session by tomorrow. Okay, but here what we need to complete the entire process. And there is also one confusion matrix. Okay, so this will be always two-by-two order matrix comparing the actual and predicted values, showing the true positive, true negative, fast positive, fast negative. These four values will be in there in confusion matrix. Okay, and classification report, this will generate the text summary, mainly include precision, recall, F1 score, sport. So all these behind we have some mathematics formulas are there. Okay, all these we will discuss in the very detail in the coming session by tomorrow. Okay, but here just I pick the file so that once we cover the entire what is the procedure. So this file contain entire procedure how we can implement the machine learning model. Okay, so that you can also start your project to work on it. Okay, then we have the mean squared error. Okay, so how actually there is the uh, difference between the actual value and the predicted value. Okay, as much we have the less difference, we have more accuracy. Okay, so we can use MSE or R squared. Okay, these are the standard metric used to evaluate the error and accuracy of regression model. So besides this, we have some more methods are there, but depend upon which type of the model we are using. According to that, we have to apply this test for model evaluation. Okay, but for the existing model which we are using here, these tests are sufficient. Okay, now see how these we can apply. Okay, so here you can see sklearn.model underscore selection. This function you see in the step number 7. Train underscore test underscore split. Okay, so this will split the data set. Then you can see we can have sklearn dot pre-processing import standard scalar and label encoder. Okay, so standard scalar and label encoder will help us just like as I told you that in the very before session. Sometimes if the values are large values, okay, or to reduce calculation, we can uh, scale them. Okay, just like I give you example, if the salary in the one system, salary of the employees in one system, uh, someone can have 5,000, someone can have 10,000, 50,000, 1 lakh, 2 lakh. Okay, so huge difference is there. And this type of the values which are very large increase the complexity. So to reduce these values, we can scale them, okay, by using minimum maximum formula. Okay, so that's why we are using the standard scalar and label encoder, just like for placed or not placed. Okay, placed or not placed, not important for us. We need numerical value 0 or 1. For that we are using label encoder. Okay, so here you can see this statement. Encode target variable for classification. So Lee is equal to label encoder and Lee dot fit underscore transform. Which one? Placement status. Placed, not placed. So this will convert in 0 and 1. Okay. Then you can see here define input to feature and target variable. Okay, this is the x1, x. Okay, so study hours, attendance, sleep hours, etc. All these values are there, and this is the x, then y, and then y for classification. Okay, and y regression. So all these variables are there. So you can execute this cell, and after that, feature selection, splitting, all these we are doing here. Okay, so the entire data set we will have in the two variable. Okay, you can see this is the x variable. Okay, and this is the y. Y contain placement, status, and code. Okay, so this is the from real data set. Then you can see we will apply split, and always and in every model. Keep in mind, always and in every machine learning model, you have to follow all these steps which we are doing here. There will be very small change. Okay, so first we need two variable. In one variable, which will be the independent features will be there, and y will be the target value. Okay, so here we are splitting the data set 80% for train and 20% for test, as we discussed. And this is the way how you can implement. How you can implement. This is the way. See now, in one line. Always X train, X test. Y train, Y test. Okay. Then you are using here train underscore test underscore split to split the data set. Okay. Then we have X comma Y. These are two variable. This one you can see. Then we have to choose the test size, and I told you that 20%. 0.2 means 20%. Okay. 20% data set we will use for testing. Remaining 80% will be used for training. Okay. Then random state we have 42, and stratify is equal to y. And here is the feature scaling. You can see here standard scalar, and we are using scalar dot fit transform x train, and we are also using scalar dot transform x test also. Okay, so by using these, the values will be reduced in small size. Now print all these. You can see we print. So when you will apply all this complete process, and you can see the data successfully split into 2%, 80% for the train, and 20% for the test. Okay, and scaled sets and scales. Okay, so the values will be scaled. If the values are in large value, so these will be automatically scaled by using scalar function. Okay, we are using scalar is equal to standard scalar. So this will help us for the feature scanning. Okay, and now you can see here regression trend shape we have is 8006. Okay, and classification trend shape we have is 8006. Okay, so 8000 we are using for the training purpose. Total we have is the 10,000. Okay, 20% for testing. 20% are testing means 2,000. Okay, and 80% of that 80% of the 10,000 means 8,000. So 8,000 are for training, and the meaning of 6 is there are 6 variable. Okay, so after that, these are the models. These are the models which we are using here. So many models we are using here, and we will compare them. We will also test which model is more accurate after deciding, and see from the sklearn linear model, we are importing here linear regression and logistic regression. Okay, we have two types. That's why one is numerical and other is classifier. Okay, dysentery regression, and other is for classifier. Then from the sklearn dot ensemble, we have random forest regression and random forest classifier. Okay, then sklearn mean absolute error, mean squared error, R square error. These are the tests which we will use here. Okay, and here is also the accuracy score, precision score, recall. Okay, all these we will cover in the coming session, a theoretical part. Okay, here is the only the implementation part, but we can apply. But if we will not cover the theoretical part, then we are not able to understand what are the meaning of all this and the values which we are getting. What are the meaning of all these values? So theoretical part is also very, very important. Okay, once we will cover this one, and in the coming session, we will cover all the theoretical part for all these functions which you can see here. Okay, these are the models. These are three models we are using here for this problem. How we can make our intelligent tool that will predict the values. Okay, so here you can see the mean error, mean absolute error. Okay, average size of the error in the score prediction. Then we have the MSE, mean squared error, measures the average squared difference, penalizing the larger mistake more heavily. And RMSE, root mean squared. Okay, this is also very important. Express error in the exact same unit as the exam score. Okay, and R square shows the how well the model expand the variance in the exam score. So these four tests are essential for this one. Okay, so now we split the data set, as you can see here. Now we are applying here regression. Actually, this model was developed by my student. Okay, which I am sharing with you. So they are using some Hindi language also there. Regression के लिए अलग से split or scaling. Okay, means they are saying that for regression model we have separately apply split and scaling operation. Okay, so here you can see this is the regression exam score placement. Okay, so here you can see the x variable and here is the y regression, and these are the target. Okay, so here we are using the same function. You can see the same function is there, no difference. And here also the same x10 regression scaled underscore regression fit transform, and same we are using for the test. Okay, and then when you will execute, we have this output regression data successfully split into two part. Okay, then you can see here we have here linear regression, ridge and lasso. These are some tests. Okay, so when you will execute, these are all the models we are using here. These are the we have already used in the above shell where we import the libraries. Here also some missing, I think, ridge and lasso. These are missing. Dysentery regression and random forest. These are also imported here. Okay, now this is the model. Now we are using linear regression, ridge regression, lasso regression, dysentery, random forest. So all these models we are using all together at same time. Okay, so here the trend and evaluate. So here we are using the for loop. This is the result, and here we are using the for loop. See, for name model in model dot item. Okay, these are the model. Okay, so this statement the name according to the name. This will take the first model according to the name from the models because all the models are available in this single variable. So one by one, these models will be taken and passed through model fit and scale, predict and result append accordingly. Okay, so all these model one by one will be taken and will pass through here to split and after that calculate the matrix. This will calculate mean absolute error, mean squared error, R squares. Okay, all these are required here, but we will calculate all these values one by one. These are the testing value. Okay, so MAE, MSE, RMSE, R square, these values will be calculated here and append the result. So when you will execute all these, so I can try again here. I have to re-execute. I have to re-execute the entire file. Yes, it's a good question because all these are just 1 minute. Actually, these are the model name. These are the model name. Okay, all these are the models which we are using. Okay, and here these values are the testing value. Into the detail, what about all these model we can discuss in the coming session. Okay, so there are so many models which we can use here. Okay, so here linear regression, rigid regression, lasso, and decision tree, random forest. All these are the models which we can apply. Okay, so here you can see when we will, yeah. So these are the comparison. This is the regression model, comparison for the exam score. Okay, zero regression, the model, and the comparison for exam score. Okay, so the linear regression model. So here the values are just like some overlapping. So these are the you can see the just like in the comparison we have 0.6 is something. Then we have the MAE for this model 0.66. This is the 0.6 is okay. So all these are returning the accuracy. Okay, the meaning of 0.66 is 66.34%. Okay, the meaning of this value is 71.27% approximately. Okay, so the other values are not there. So here we have the, okay, this is the part where we have the testing. Okay, if you need some more interpretation about all this, we can copy all these. Okay, so here what we do, we just tried how we can implement the model, but this is the not the complete model. Okay, we have to take some database. Okay, so here only up to testing part, how you can develop the model and how we can apply the testing. Okay, only this part is there. So there is also one other data set. Okay, we can copy and come here for more interpretation. So here the one thing is missing because theoretical part, which we did not cover here today, we will do all these tests which are essential. Okay, because during the one session, we can only describe all type of this complete process, how we can use it. Okay, so here you can see these values. Okay, and interpretation, linear regression, redirection, lasso, these are the models and these are the value. And you can see best performance based on MAE. And here you can see this is the list error. Okay, these values are sorry, these values are MAE, mean absolute mean error. Okay, so if the error is less, it means we have more accurate. So according to this model, we can see that the descent tree is the best model. Okay, so mean error is at this basis very less. And here in this model, when you are using this model, it has this model has highest. Okay, this is the highest among the all the models. So this is the best one. Dysentery for this problem. Okay, So here, more interpretation you can see here, entire report you can see. But yeah, also this is very intelligent tool. All the formulas which are essential here. Okay, I want to present this model. So you can see MAE will be equal to 1 upon n, summation I equal to 1 to n. Yi is the actual value and yi cap is the predicted value. So the average difference of these is MAE. If you are using MSE, then this will be in the place of models we have square, whole square. Okay, and RMSE will be square root of this value. And if you need R square, this will be calculated by using this formula. 1 minus summation yi minus yi square, yi cap whole square upon yi minus y bar square. Okay, so this is the formula which we can use for to get all these values. And on the basis of all this, we can compare the error between the actual value and the predicted value. And according to that, we can compare them and we can decide. Okay, so here you can see there's a recommended Python evaluation is also there. So all the models which we are using here, you can see the corresponding their output. Okay, so in this way, you can also integrate a little bit for the detailed interpretation, generative AI tools. We can have more information. Okay, so this is the entire complete process, how we can use, what will be the complete process for model splitting and training and the errors to check the which one is the best model. Okay, after that also the some part is there. After training, we have to implement for testing. Some other tests are there, just like confusion matrix to validate the model. Okay, but here, this test we are using only to compare the model, which one is the best. Okay. So this part, which you can see here, we will cover in the coming sessions, and along with the yes, you can see here the confusion matrix and the other are there. Okay, so the complete theoretical part is there. So this part is very, very important. Okay, so all these we will discuss in the coming session by tomorrow, and partially some theoretical part which is missing, that also, so in within 2 days this model will be completed. Okay, so what you can do now, you have to choose one data set, and up to this part, up to this part you can implement for your model. Okay, so first you have to choose the problem, which type of the problem you want to solve. Okay, just like if you need the data set also. First, please let me know if there is any question related to this content which I present here, except the theoretical part which is necessary to cover for this section 33. Okay, before that, if there is any question, please you can unmute my, you can ask your query. Yes, anyone?
So from where shall you get the data set? Where from shall you get a data set?
Yes, please.
Where from shall you get a data set? And what type of
Data
data
set.
set? Yes, sir.
Okay, how you will collect the data set? Okay.
No, where from shall you get a data set? If you have to get the data set, if you have to get the data set, from which site will get the data set? From which repository we shall get the data set?
Yes, so suppose that you need the data set of, are you familiar about the Kaggle?
No, I have
How
heard
many
only.
participants are?
I have heard only. I have not used.
Okay, you have the data set.
No, I have heard only. The Kaggle site I have heard, but not used the
Okay,
data.
okay. See, very simple. Very simple. This is my, okay, first I have to share my screen. This is my screen. Yeah. So here you will, in which area you are working?
Any biomedical,
suppose
clinical data we can take any.
Yes, clinical data. Okay. So for the clinical data set, Kaggle. Kaggle have a lot of data. Okay. So you are required to come to this kaggle.com. And if you are not registered, you can register here. But I am already, so I need to log in it. Okay. So here, clinical data set. Okay. So you can see ADA on COVID-19 clinical trial. Then you can see the reply to, okay. I need to select only this one. Or you can use by using the term healthcare. Yes, you have a lot of data. Okay, you can see a lot of data is there. So you can select anyone. Suppose I need healthcare cost prediction and linear regression. Healthcare data set. Okay, I can check from this place. See this example, healthcare cost prediction and linear regression. Okay, if you need only the data set. So see insurance.csv. Okay, this is the data set. You will click on it. How I can download? Or we can download from this place. Download.I. Okay. This is the file of the model. Okay. And when you will scroll down, view the data set. And here, compact. This is the entire data set you can see here. Okay. And insurance CSV. This must be downloaded. Close. If I have the code discussion suggestion, view more. I can try this one. Actually, I think this will contain data set along with the Python code is also there. Python code also will be there. For the training purpose, all the data scientists, when they have some insight, okay, they upload their project here, which can be beneficial for beginners. Okay, so I can open it. Yeah, data set is there only. Insurance, this is the data set. When I double click on it, you can see data is there. Okay, and this is about 1338 entries are there. Okay, so there are various options here. You can see multiple data set are there. So depend upon how much large data set you need. So according to that, you can find out the data set. Okay, so here various examples you can find here, or otherwise also you can find here healthcare data set, at least 10,000 entries. We can use in this way also from Kaggle. So alternative large healthcare data set on the Kaggle. Yes, we can select this one. Okay, so this is the healthcare data set. And when we will download this data set, unzip the folder. Okay, open. Yes, this is asking Microsoft Excel. Don't convert. You can see this is very large data set related to healthcare. About these are more than 55,000, very large data set. Okay, now depend upon how you can use it. Okay, so there are all type of the data set you can find from Kaggle, related to the breast cancer, diabetes. Okay, just you must have your login account, and some of the data scientists provide the coding part also. Okay, just like if you want to see, if I download from this place, what this will download. Okay, data set. Okay, by using this icon, we can directly download this CSV file. And if you will select on code, this is the code, right? And this is the notebook. Yeah, you can see the notebook is there. Okay, so from this place also you can take help with the Python code entirely will exist with respect to that particular data set which they have used for analysis. This is the healthcare data set, and all the operations you can see the output will be there. These are the inputs, and here are the outputs. Okay, output not showing, but the Python code you can see here. Okay, step by step, all the operations you can see. As we do in the Python geometry file, in the same way, all the operations are here, and you can also directly understand this entire data set, what type of operations they perform, and what are the insight by using this one. Okay, this is the next step, data understanding. Okay, these values we have got also in our operation. Then you can see the column list are there. Then data cleaning is there, also there. All the operations are there. So here, by using the Kaggle, I request to all the participants, you have now good background how you can use Python. You have good background about the statistical method, and if not, we can do. Okay, and for the learning purpose, we need some data set, and without having the data set, we are not able to develop any model. So first is training and learning. For that place, for that purpose, if you are using Python, so all the data set along with their implementation, as you can see here, is available. But the thing is how you are using. You need only one thing. Your account must be there on Kaggle. So lot of information, lot of data is there for each type of the problem. You can easily go through here. Okay, and I hope that with the help of this Kaggle, you will create your account and you can access all type of the data set according to your problem. You can choose here on problem. If I suppose that you want to do some uh, crop prediction or disease prediction, crop disease prediction. Okay, all type of the data set you can find from this place, and you can use, and some of the authors may have, I'm not sure, but may have complete process to deployment of the model. Okay, but here in this workshop, we will cover only how we can develop machine learning model. And if the model is trained, after that, the next level is how we can deploy the model. And deployment means to develop any web application or mobile application so that users can use that technology. Okay, so we need to expand our knowledge and we need to expand our skills and everything we can do. So Python is, you can see, quite easy, and various models. Today, one model I try to present here, and by coming day, within 2 days, the other things which we need for the machine learning, we will cover everything. And with some of the statistical part is there. So we have today is 25. 4-5 sessions are there. Okay, these are enough. So I request to all of you, you can choose any data set and try to implement the same process for your model. Okay, so that till the end of the last day, you can easily complete and submit the same. Okay, any more question, please? Any more question? Dear participant, any more question?
Sir,
Yes, R. Sheila. Yes, ma'am.
sir, when the FTP starts, sir? But I joined Sunday only, sir.
Pardon?
When the FTP started, sir? This FTP, how many days, sir, went?
Can you write me? Actually, I don't get your question, what you ask. Please text me in the chat box.
Okay, sir.
Yes, please text me. Okay. How I can check my data is balance? Okay, we will cover in the coming session. Okay, what do you mean by the balanced data? Okay. Okay. So you will get the answer in the coming sessions tomorrow. Because I have to demonstrate along with by using the data set. Okay. So I have copied your question and you will get the answer in the coming session tomorrow. Yes. So dear participants, this is all about the today's session. Okay. And time is about 9:45. I request to dear Face, can you please conclude the session? Okay, he is not there. So, okay, dear participants, this is all about the today's session, and I hope that this is informative and help you for the to develop the machine learning model. Okay. Suppose I take 80% non-stock and 20% for stock. Okay. Okay, all the questions remaining we will cover in the coming sessions tomorrow. If there is any question, now you can put in the chat box, in the WhatsApp. Okay. Because for this, we need some data set, and by using the data, we can, you can have a better understanding. Thank you and good night.
Good.